Alright guys, I haven't studied system design in a while, so I'm gonna go ahead and just see what I know from the top of my head, like from scratch. So, if you guys don't know what system design is, it's kind of just figuring out how the internet works. So, an example, a common interview question would be like what happens when I type a URL into my web browser? Like, what happens under the scenes? Well, I'm gonna just try to answer that first. Okay, let's see. So what happens when I look up URL in my web browser? Okay, so what even happens? I think what actually happens is there's something. Okay, so usually you have something. Let's just say, let's go. Let's just say you have some website called Eric Tree. All right, erictree.com. So basically, what this is just kind of just a domain name. It's gonna be called domain, right? But it doesn't really actually do anything. This actually is going to map to an IP address, something like one point. I don't know, just a bunch of randoms, right? This will actually map to let's just IP address, right? And what this does is that it gets your domain and it changes it to an IP address using something called the DNS. DNS, which is stands for domain domain naming service. Right? So that's what it does. But what actually happens after let's say your address that you sent turns into an IP address? What it does is that your local machine, which is say, let's just say local machine is just like a PC or something. Um, Let me go back. It's like a PC. Oops. It's like a PC, right? A local machine. Right? Will actually just send a request to the server. What is the server? Well, the server is whatever's hosting erictree.com or whatever's hosting that IP. So it's kind of like my computer is talking to someone else's computer, right? But that someone else's computer is usually called a server. So they do something called, I think, a three-way handshake. So to make sure that that domain is even a real thing, your PC sends a ping, right? So let's just say this is I'm just going to say LM, local machine. It sends information to the server. Let's just say Eric Tree. So Eric Tree. And then Eric Tree sends back another request. It's saying, hey, we're here. We are here. Or actually, we exist, right? And then your local machine sends another request back saying, cool, cool, I got your message. Your message, right? Then once that is established, right, this is called like a three-way handshake. Three-way handshake. Right, once this is established, what actually happens is that the server will send the server will send an HTML file, which is basically just a file with a bunch of instructions. Right, it'll send an HTML file over to your local machine. Then your local machine could go ahead and read that file. Reads the HTML and this displays it using your web browser. Whatever web browser you're using, let's say Google Chrome, Safari, whatever you use, it goes ahead and displays it, right? But sometimes your website will actually make a request. For example, if you want to like post a comment or something, post a comment. And then you'll actually send a request. This is usually called using a REST API, which uses post, get. I think another one was like post, get, delete. Oh, where'd my pen go? Delete. Post, get, delete. I think another one was like update. I feel like update was post, get, delete, write. Maybe write was it. Okay, so they go ahead and send an API, and it just updates their database. By their database, I mean the server's database. And that's basically what happens for when you look up a URL in the web browser. But system design is way more than just that. Because sometimes before going to the server, there's actually multiple servers, right? Because there's something called horizontal scaling. Oops. Oh my gosh. There's something called horizontal. Versus vertical. This is scaling type. This is referring to servers actually. So vertical is kind of like you upgrade your machine. So let's just say your computer runs pretty slow, right? You have a slow computer, right? So vertical scaling is kind of just upgrading it. It's like upgrading this shit. You upgrade. Maybe you get like a new fan for your computer so it gets cooler quicker, something like that, right? It just kind of upgrades, right? So this is gonna cost a lot, right? Well, horizontal scaling, it's like instead of upgrading your computer, you could just multiply your computer. So you could just have a bunch of just slow computers. I wouldn't say slow, but just like not as fast as the vertical one. But yeah, you get a bunch of a bunch of computers. So usually what goes with the horizontal computers is you have something called a load balancer. Right. So going back to what happens when you look in your web browser, um, when your local machine talks to the server, sometimes it doesn't even talk to the server at all. Instead, it talks to the load balancer. I'm just going to say the LB, right? So what the LB does is kind of like, okay, so this is your local machine, your LM. It talks to the load balancer. I'm just going to say LB. And LB is just say, I don't know, let's just say it's a big ass square, right? And then you're gonna have a bunch of servers like this under that. So basically what the load balancer does is it kind of just distributes all the requests because one server could get hundreds of requests, right? And instead of just overloading 100 requests on one computer or one server, we just balance them out. That's why they call it load balancer. So you want to balance out the requests to each of these servers. There's a bunch of algorithms that happen or that they use to go ahead and balance it. One notable one is probably round robin. That this one shows up a lot. Um, Round robin. So this one kind of uses a time quantum. So you have to figure out the time quantum. Usually it's like some sort of queue thing. It's like say like 30 milliseconds. I don't know. um, So yeah, it'll give like this one. This server gets 30 seconds, 30 M. I'm just gonna say 30 M. This one goes 30 M. Then it just context switches all the time. That's what the round robin algorithm basically does. But yeah, people. I think companies really like horizontal scaling versus vertical. I mean, I guess you have to do both horizontal and vertical. But horizontal is definitely like the new idea, it's a new kid on the block. People like it a lot just because, let's say, if one server fails, I'm just gonna say red. If one server fails, for example, let's say this one, right? Server number 2 doesn't work anymore. Then we still have server number 1, server number 3, and server number 4 working, right? Versus vertical, right? Vertical is like instead of a bunch of small ones like this, right? Let's just say this is horizontal. Right? Instead of having this a horizontal scaling, a vertical scaling would have one giant server. Let's just call this a massive server, right? Um, this would be one supercomputer, but it's actually like if it fails, then there's no backup. Oops. Right? That's why horizontal scaling is preferred right now. Let's see, is there anything else that has to do with system design? I think another one would be they have a lot of auto scaling, which is kind of like let's say at this hour, let's say at hour 6, right? Sometimes there's like we have multiple servers, but we don't want to keep servers running even though, let's say, like there's not that many people. So we have something called like auto scaling. With auto scaling, we use a smart algorithm which could kind of figure out when traffic is heavy and when traffic is light. So let's say when traffic is heavy, we would run all 4 servers which we have available. Well, when traffic is light, we could just take away 2. So we could just only run 2 servers. Therefore, we don't have to pay as much. There's also something called durability is a big part. But this is kind of just for like big companies that have servers. So durability is kind of just like the pain tolerance. So let's say we have multiple servers, but they're in different locations. This is called this location 1. Right? And then we have another server in location 2. So by splitting these servers, like let's say they're in the same power line. So this one uses, I guess, power from PG&E, PG&E, right? And this uses like power from somewhere like solar power, right? So the point of having 2 different locations and 2 different versions of power is that when one thing shuts down, because stuff is unexpected, right? We have to prepare for that. An example would be like if we didn't prepare for a natural disaster and our service would be down, we're actually losing a lot of money, right? So to have our system be durable, we actually plan for any future disaster that might happen. So we have servers that run from solar power, and we have servers that run from power we get from PG&E. And that's kind of like the durability aspect of system design. There's also different locations. So sending a ping, right? So there could be like cell towers. Let's say one is in like, I don't know, uh, let's say we have one at USA and one in, let's say, Singapore. Right? So when I send a request, let's say I live in Texas, right? And this is the client. We call users client, right? If the client in Texas sends a ping to Singapore, right? The ping would take probably like 5 seconds, which is a long time, I guess, for sending pings. Well, if I just send one to USA, then it would only be like 1 second. right? But let's say if we had another user in Singapore, whatever city is in there, right, and they sent a ping to USA, that would take 5 seconds. But if we sent one Singapore to Singapore, it'd only take 1 second. Right. This is another reason why we should have cell towers wherever, or we should have our server running in many locations, just so that because our product is more accessible from wherever you are. So that's another thing to keep in mind when doing system architecture. Let me see what else is there. I know. Let's talk about storage. I think there's three different types of storage. There's one which is like an object storage. Which is kind of like you have like MP3 and you separate stuff by MP3. Let's just say like a PDF, right? And then there's another one which is like I think it's kind of like physical storage but in the cloud. I don't know. I just want to say it like block storage. It's kind of like this, like a hard drive, or this will be like drivers. I don't know. And the third one would be it was kind of what kind of was the third storage again? I think it was like Redbox or something. That was like the service. What the type was? I think maybe relational database. Yeah, like a relational database. Um, what else was there? I guess there's the ACID principles. But I think we're swaying outside of system design. That's kind of like database management. All right, I think that's what I got at the top of my head right now. It's like almost 12 a.m. Maybe I'm just a bit sleepy. That's why I can't really think of nothing. I definitely know that there's more out there, but this is what I got right now. And I haven't studied in a bit, but I just wanted to see where I was at. Yep, thank you guys for watching. See you later.